Don Machholz, and you are listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 75 for the week of June 9th, 2021. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ, 2 H's. What's up in the sky this week? As our week begins on Wednesday, June 9th, the moon is a tiny crescent in our morning sky on the way to an annular solar eclipse on Thursday, June 10th. We discussed that solar eclipse last week with eastern Canada, western Greenland, the North Pole, and eastern Russia seeing an annular eclipse. Much of northern Europe and northern Asia and parts of the east part of the United States will see a partial eclipse. By next Tuesday, June 15th, the moon will be 25% full, still a crescent in our evening sky. On the evening of Friday, June 11th, more than a day after the eclipse, a slim crescent moon will be very close to Venus in the evening sky. Venus and the moon together in our evening sky. A challenge worth a try. For the Western Hemisphere, that is, North and South America, the moon will be below and to the right of Venus. Exactly where in relation to Venus will depend upon where you live and when you observe it. As a gauge for distance, there is a 3.1 magnitude star, 1.6 degrees to the west and slightly north of Venus. For many of you, this star is more or less between Venus and the moon. Seen from the east coast of North America, at twilight, the moon will be 3.5 degrees below and to the right of Venus. Now that star, once again, is 1.6 degrees, almost in the same direction from Venus. From the east coast of South America, twilight comes a few hours earlier, and the moon is 5.5 degrees directly below Venus. For the west coast of South America, a few hours later, the moon will have crept closer to Venus, traveling at about 0.5 degree per hour. The moon will be about 4.2 degrees below Venus. And as seen from the west coast of North America, the moon will be even closer to Venus, and some northern locations will see the moon occult the star Epsilon Gemini, magnitude 1.6, which is 1.6 degrees below and to the right of Venus. By the time it is evening in Hawaii, the moon will be passing northwest of Venus at a distance of 1.5 degrees. And when it's twilight in Japan, beyond the international dateline, the evening of June 12th, the moon will be about 1 degree above Venus. Remember, a binocular field is typically between 5 and 7 degrees for handheld binoculars, while larger binoculars have a field of view of 2 to 4 degrees. So most of you can fit Venus and the moon in the same binocular field of view. All this action occurs 20 degrees from the sun, so you need to get out there while it is still twilight. Use binoculars or a telescope. In fact, try finding Venus shortly after sunset. Then see how soon after sunset you can pick up the thin crescent moon as both are heading towards the western horizon. Now, finding the moon on the evening of Friday, June 11th would mean you're seeing the moon about 40 or 50 hours after new moon. Can you do better than that? Can you find the crescent moon the night before on Thursday, June 10th? Depending upon your location, this is 14 to 18 hours after new moon. On that evening, it sets only about 30 minutes after the sun. But give it a try. If you find it, good for you. If you cannot see it, then you will understand the difficulty met by those who find it only 12 hours after new moon. The moon continues through the evening sky, and on Sunday, June 13th, the moon passes north of the planet Mars. But by this time, Mars is dim, magnitude 1.8, so this will not really be a spectacular event. Saturn now rises late in the evening, followed an hour later by Jupiter. Will you be able to see the International Space Station this week, which for our purposes begins Wednesday, June 9th through Tuesday, June 15th? This week, we have 5 zones. All you need to know is your latitude. A lot of you won't be able to see the International Space Station this week unless you pack up and move. North of 20 degrees north, and that is most of you who are listening to this podcast, you will not see the ISS at all this week. And most of you won't see it the week after that. From 20 degrees south to 20 degrees north, the equatorial region, the ISS will be in your evening sky for at least the first part of the week, then in your morning sky for the last part of the week. Further south, from 30 to 20 degrees south, the ISS will be in your morning sky for the first part of the week, and in the evening sky for the very last part of the week. From 48 through 30 degrees south, the International Space Station will be in your morning sky for the first part of the week, and then it will be gone. South of 48 degrees south, you won't see the ISS at all. To determine where it will be in your sky, go to the website heavens-above.com and enter your location, then click on ISS. You can also find at heavens-above.com the location of almost any satellite. Periodic comet 7P Pons-Winnicky is still in our morning southern sky, now about 10 degrees south of Jupiter. In the past week, it outburst in brightness twice, once reaching 10th magnitude. Comet 7P Pons-Winnicky is plotted on podcast 74, map 4, and positions at his right ascension and declination are on podcast 74, comet positions. Now for the astral class, using star charts. In the early 2000s, I wrote an astronomy article each month for a new publication called the Colfax Area Express, Colfax, California. This is something, by the way, that almost any of you could do. I discussed the sky for that month, the planets that are visible, upcoming eclipses and meteor showers, and the dates and the locations of our public star parties. I also included an all-sky star map showing where things are in the evening sky. After a few months, the editor contacted me and said the column was being well received with only one complaint. That complaint? The east and west on my star maps were reversed. Most Earth maps we have north at the top, south at the bottom, west at the left, and east at the right. These maps are oriented as seen from above the Earth, looking back towards the Earth. Well, in that case, west is to the left and east is to the right. But a star map is different. We use it from Earth facing the southern sky. In this orientation, west is on the right, not on the left, and east is on the left. So my star maps were correct. The reader was not using them properly, or not using them at all. I use a computer program called The Sky by Software Bisky to make the maps for this podcast. Every podcast has sky maps, one for the evening sky and one for the morning sky as seen from the northern hemisphere, plus additional maps for comets and other highlighted objects for the week. Many apps are now available which produce a sky map for you, and the website we use for satellite predictions will also produce a live sky map for you. It is heavens-above.com. The all-sky star maps have a circle somewhere on them that depicts the horizon. Everything inside the circle is above your horizon. The center of the circle, by the way, is exactly overhead. Everything outside the circle is below your horizon, and it is in one of three categories. Those objects have not yet risen in the east, they have already set in the west, or they will never rise above your horizon. In order to produce one of these all-sky star maps, I need 3 bits of information. They are the location, the date, and the time. If you give me your location, it tells me how far north or south you live. For those in the northern hemisphere, if you live far north, then most of the sky map will show the northern sky. If you live far south, then most of the map will show your southern sky. Your latitude tells me how much of the northern sky is in your sky, and how far south you will be able to see the southern sky. If you live in the southern hemisphere, how far north or south will tell me how much of the southern sky is in your sky, and how far north you'll be able to see in your northern sky. This information helps me to set the horizon circle. Your longitude will also give me some idea of the universal time that the map is drawn. Now, the object that moves the fastest from one day to next is the moon. It moves its own diameter about half a degree every hour, which amounts to 12 degrees per day. So as the sun sets across the world, as it will do this Friday, the moon changes over the course of one Earth rotation, that is, one day. If you listen to the first part of this podcast, I described how the fast-moving moon changes in relation to the slow-moving planet Venus. People in different parts of the world will see the sunset and immediate western sky at different times, and they will see the moon in a different perspective to Venus depending upon exactly what time they see the scene. This is why I set the scene for the eastern coast of North and South America, the west coast of North and South America, Hawaii, Japan, and Australia. They might all see it on the same day or within a few hours of each other, but those hours make a big difference when we consider the moon's motion across the sky. Next, in order to draw a star map, I need to know your date, the date for which the map is created. Again, the moon moves through the sky, changing by about 12 degrees per day. While Venus can move about a degree per day at its fastest, and Mercury not nearly as fast. Mars, Jupiter, and Saturn move more slowly. If I gave you 2 maps drawn for a week apart, you would definitely notice that the moon is in a different place on each map, and probably Venus and Mercury. Maybe Mars, and probably not Jupiter and Saturn. You can do that experiment now. Look at the maps that I produce for each podcast, drawn a week apart. Do you notice the differences? Also, as the Earth goes around the sun, our perspective changes by about a degree per day. The sun moves eastward against the stars, and that means each evening we lose part of the sky into the western twilight. Not all is lost because we gain a small part of the sky each morning in the eastern sky. This is what gives us our sky seasons. For instance, presently, our winter objects have already set in the west by time it gets dark. That includes Orion and Auriga and other such constellations. They will be back in our morning sky in August after they go behind the sun. Meanwhile, up overhead each evening, we have the spring constellations, Leo, and the whole stretch from Ursa Major in the north down through Virgo, Corvus, and Vela in the south. They are in our evening sky now, the spring constellations. Rising after dark and high in our sky around midnight are the summer constellations, Cygnus through Sagittarius, also known as the summer Milky Way. Then in our morning sky near morning twilight we find the autumn objects. All these things we find now. Give it a few months and everything changes. So to draw the all-sky star map, I need your location, the date, and finally the time. This is because the Earth rotates. What we see in the sky at 9 p.m. will not look the same at 10 p.m. Everything rotates around the poles. When you face the North Pole, the sky rotates counterclockwise. When you face the South Pole, it rotates clockwise. So the time for which the star map is made will affect the placement of the horizon circle on that map. The maps that I include in these podcasts show the evening sky, that is usually map number 1, and the morning sky, map number 2, from my house in Stargazer, Arizona. Some of you might have looked up Stargazer, Arizona, and found nothing. There is no Stargazer, Arizona. I live on Stargazer Drive, about 30 miles northeast of Wickiup, Arizona. We did not name the street Stargazer. It was already named that about a decade ago. The property my wife and I originally looked at in this subdivision was on Flea Flicker Drive. So we could have been living on Flea Flicker. But that property was not very level, so that day, 4 years ago, we hopped back into the truck, four-wheel drive, and looked for other properties. That 3-mile drive took us to the southeast corner of the subdivision where we found this property, Stargazer Drive. I am not making this up. As we turned into Stargazer Drive that day, we knew we were on Stargazer, but would not have bought the property if it was not a good location, dark skies and low horizons. Maybe someday you can have your picture taken standing next to the Stargazer Drive sign. More about that later in this podcast, but I have digressed. Stargazer is about 35 degrees north latitude, so the star maps are made for that latitude. If you live a few hundred miles north or south, and each degree of latitude is 69 miles, which is 110 kilometers, you will not notice much difference between what the map shows and what you see in the sky. So that would be between perhaps 30 and 40 degrees latitude. Do note that if you live south of 35 degrees north from where the maps are drawn, then more of the southern sky is above your horizon than what the map shows, and less of the northern sky is above your northern horizon than what the map shows. Likewise, if you live far north of 35 degrees north, then less of the southern sky will be visible in your sky than what the map would show. As for the date that my podcast maps are drawn, I usually draw them for the weekend, Friday or Saturday night. The morning ones are drawn for the following morning. And our third element, the time for which the maps are drawn. The evening one is for more or less the end of astronomical twilight, when the sun is about 18 degrees below the western horizon and is dark enough to do serious observing. If you go out an hour after that time and look at the sky, everything has rotated a bit. Those objects in the western sky are now lower, while those in the eastern sky are now higher. The morning sky maps are drawn for the start of astronomical twilight, once again when the sun is 18 degrees below the horizon and moving up. What objects will be high in the sky at midnight? Well, look at the areas in the eastern sky on the evening maps, the left side of those maps. They are rising, and over time will get higher in the sky. Also look at the areas in the western sky on the morning maps, the right-hand side of the morning maps. They have already been overhead in the previous few hours, and now in the morning they are setting. If you want more accurate maps for your specific location and a specific date and time, use one of the many apps available, a so-called planetarium program, and or a website like heavens-above.com, and generate a custom-made map just for you. So how do you use those all-sky star maps? Face south. Your sunset point will be to your right. A funny thing is that when I draw up custom maps for the southern hemisphere, they face south too for their star maps. So everyone faces south. South is at the bottom of those maps and north is at the top. Hold the map up towards the sky over your head. This might take two hands, one to hold the map and one for your flashlight. A dim and/or red flashlight will preserve your night vision. Everything inside the horizon circle is above your horizon, where the sky meets the land. Everything outside the circle is below your horizon. Now, what if you want to look in another direction besides south? You can do that, but you must rotate the map. Let's do an about face and face north. Now you must turn the map upside down so that north is down and south is up on the map. All of the labels are upside down, but you can read upside down, can't you? If you face east, then east is down on the map. If you face west, then west is down on the map. It's just a matter of rotating the map. Maybe you thought that when I said we would discuss star maps this week, it would be a short, simple discussion. Face south and hold the map overhead. I've added so much more this week to give you a better understanding of star maps. Next week, I'll discuss the eye, the human eye, and astronomical vision. Our highlight object for this week is the globular cluster M5. It is located off of the constellation Virgo, and it is shown on podcast 75, Maps 1, and a more detailed Map 3. Now, for the unaided eye, the other night I saw M5 with the unaided eye. It was not difficult to see. It's magnitude 6.2 and 10 arc minutes in size, which isn't much different than M13. If you can see M13 in Hercules, then you can probably see M5. Give it a try. In fact, if you have dark skies, try for M3, M4, M5, M6, M7, and M8 with the unaided eye. Through binoculars, M5 looks like a tiny fuzzball. There is a star of 5th magnitude 23 arc minutes to the southeast of M5. Notice how condensed the object looks in binoculars. Through the telescope, start with low power. The cluster is not symmetrical, it's not quite round. Look for streams of stars emulating from the center. Crank up the magnification and see how far into the core you can still resolve the stars. Now for fun with the marathon. The Messier Marathon is the attempt to view all 110 of the galaxies, clusters, and nebula cataloged by Charles Messier more than 200 years ago. His catalog is known as the Messier Catalog. The best time to do this is in late March of each year. But the marathon can be done any time of the year, but it will yield fewer than the 110 objects. As we move into summer and nights get shorter further north, the Messier Marathon time span shrinks to only 3 hours. So there you have it, the 3-hour Messier Marathon. Now I'd like to make an announcement. Earlier in this podcast, I talked about our home here in Stargazer, Arizona. My wife and I are now ready to receive guests, that is, amateur astronomers who want to observe from our ranch. You can RV here, but we also have an attached guest suite you can stay in. The cost to stay here for a couple days is nominal. We can leave you alone while you observe during the nights and sleep during the days, or we can interact with each other and I'll observe the skies with you. We could even do a Messier Marathon together any time of the year. You can bring your own telescope and/or we have several here that you can use. For those new to astronomy, we can spend 2 or 3 days and nights together, during which you will learn all there is to know to get a good solid start in visual astronomy. We live a 3-hour drive from Phoenix, 3 hours from Las Vegas, 3 hours from Flagstaff, and 3 hours from Prescott. And we live 1 hour and 15 minutes from Kingman, Arizona. Our ranch is near the end of a 19-mile dirt road off of Highway 93 in northwestern Arizona, and the turnoff is about 10 miles north of Wickiup. 4-wheel drive is not needed to get to our ranch, but it does make things easier. If we have a lot of rain, which here is more than a half an inch at a time, the roads are difficult to impossible to transverse and for the next few days after the rain due to mud. If that be the case, we would have to reschedule. If you are interested in staying here at the ranch, email me at dontheastronomer@gmail.com and we'll get started on setting things up for you. To recap the podcast, what's up this coming week? The Moon and Venus meet on the evening of Friday, June 11th. Don't miss out on this one. And try to find the moon the night before, Thursday, June 10th. It will be a difficult target. Use star maps to find your way around the sky. Observe N5, and if you are so inclined, write me about a stay here. You have been listening to Looking Up with Don, podcast episode number 75 for June 9th, 2021. I'm Don Machholz. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com, 2 H's. You can contact me at dontheastronomer@gmail.com. Once again, that is dontheastronomer@gmail.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We'll learn about the eye and how it sees in the dark. All that and more. Thank you for listening. See the sky this week. I'll see you next week.